XDF, looking at Advent of Code 2021, Day 14, Extended Polymerization. Basically, my input is going to be, the first line is a starting point, and then I'm going to have this list of rules. And the rules basically says, so like, I take these as a pair. So if I start with NN, and then I find it here, and that becomes, I put a C between NN, so it becomes NCN. I also then take NC and make it NBC, and I take CB and make it CHB. And so I do a full lap through here and so I'll put 3 in here. One here, so where's it? So like there's my NCB and make a new string. So each time I do this, the string is going to double in length minus 1. Right, because I'm going to add, there's 4, I'm going to add 3. Here there's 7, I'm going to add 6 more. So this will be, 13, etc. So I've got exponential growth here for sure, which right away means I'm going to have to think about a way to solve this that's not linearly stepping through here, because that will not, well, I'm going to guess, just knowing Advent of Code, it's going to work for 10 steps here, and then the next one's going to say, go 100 steps, and that's going to be, so I'm dealing with numbers in the thousands here, and I'll be dealing with millions, maybe more. So I'm gonna have to have the obvious approach to just walking the line or inserting things is probably gonna work in the first step and probably not in the second. So anyway, then once I get to the end, I need to count up the elements by type and subtract the most common from the least common from the most common. So let's go ahead and get started. Start with some Python. So we'll do our normal read in the file given as the first argument, SF. And so in this case, I'm gonna go ahead and just read in input equals f.read, so I can do a split then. Actually, I can do dot split, like a double new line there, and this will give me start, comma, and what do I want to call the rest of it? Patterns. And now, so start will be, let's see, I definitely want to, let's see. So start equals, actually call this S just to save myself time. S equals start.strip. There we go, that's easy. And then the patterns, so I want to do for line in patterns.split. I probably need to strip this because I don't want to get the last one, and then dot split on new line like that. So now I should be able to looping over all of the lines. Let's go ahead and open up 14 example dots. There we go. And so then I will do, I'm going to need some sort of cookbook. I'll call it C equals, we'll make it just like that. So I can just do pair comma new equals line dot split. Strip it again. Strip dot split on like that. So that should give me the pair and the new, and then I will say C of pair equals new. Now at the end of this, I should have. Let's go over here. Python 3 minus I, day 14 example. So now I have start, which is my starting string. That looks good, and I have see, let's see. I think I have S as well. Yeah, okay. I don't know if I really need. I can clean up a little bit here just to make sure I don't screw things up. So I've got my C, which is like my lookup table, and I've got S, which is my starting string. I haven't figured out in my head yet what the efficient way of doing this is that I'm going to have to do in part 2. So I'm going to go the route of doing it kind of just in a loop. So we're going to do for t in range 10. We're doing it the first time. Now each time we're going to step through. So we're just going to do for I in range len s. And I think we need to do -1 because we don't actually want to hit the last one, right? Because we're taking them in pairs. So we're going to want to go 0 takes those two, 1 takes those two, 2 takes those two, and then we stop. So I think that looks good. And now we're going to need like, let's see, we'll need like new, use new again, use n equals like that. So n plus equals s sub I, n plus equals, let's see, and then we need c of s sub I plus s sub I plus 1, right? So I'm getting, so in the first example, when I is 0, I'm going to add the n. Then I'm going to get n and the other n, and I'm going to look up in the table and get whatever that value is. Should be coming faster to me, but I can't find it for some reason. There is c. I'm going to get this. I'm going to add c to the thing, and then I don't add. So I'm not going to add the next one because that's going to get added in the, if I added the second n here, then when I'd add it twice, so that would not work. But that does mean when I get to the end of that loop, I need to do n plus equals, or actually. So I'm going to say, I'm going to build this whole new string, and then at the end of the loop, I'm going to set s equals to n plus s minus 1. So basically, I'm adding the last character back on. So my next round s will come back up here, and I'll loop over s again. So I'm going to use this as the next. So s is the string, n is the next string. I'll build n up, and then I'll set it back to s to do my next loop. And then let's see if that worked. This is long. This is 3073 long. Let's see. That's not what I was looking for. What if my there we go. Let's see, what am I looking for here? The most common and the least common. So B had 1749. I don't know the right way to, or C in S if C equals B. Len 1749. That feels good. Okay, so we'll use a counter here. So we can do from collections import counter s x equals counter x sub b, like that. Oops. Okay, that looks good. X dot values max 1749, min 161, $15.88. Was that my answer? That was my answer. So we can do counts equals counter. I'm gonna have to remember to import that. S print part 1, and then we'll do max dot values minus min counts dot values. That max, that's that. Fix that. It's not S, it's counts. See if that works. Counter. I said I needed to import it, and then I forgot. From collections import counter. $15.88. That's correct. Let's try it with the puzzle input. 2233. Sweet. Part 2. How much longer is it going to get? Let's see. It's short. Okay. The resulting polymer isn't strong enough. You need to reinforce subrange. Your more steps. A 40-step process should do it. Yeah, look at these numbers here. So there's no way. Now we have, the shortest element is, there's 800,000, 800 million, so 3 billion. The shortest one is 3 billion, and the longest one is 1 million, 2 trillion. So there's no, we're not going to be able to do that. I guarantee we can't do that. I could show it real quick if we want. Let's see. Let's do this. We'll go if t equals 10. And put this here. Oh, this isn't going to work, so I'm not sure why I'm taking time to do it, but replace 40. It gets there instantly, and then it's just hanging. In fact, we can, let's just for the sake of print t comma len s. So it got to 10 pretty quickly, and it is very quickly here calling to a stop, and I'm only at 20. So and my computer fan, I don't know if you can hear it, but my computer fan just like roaring up in the background. So we're stopping. That's never going to work. Okay, so we'll get rid of that. We'll come back and fix this. So let's just, we'll do this because I'm gonna undo. There we go. Okay, so we need a new approach. I'm going to actually pause the video here for a second and think about what my new approach is, because it's not obvious to me yet, and I don't want to, sitting here and thinking on camera is probably not the most interesting video. Okay, I got an idea. So what this comes down to is every time I have an NN, I'm going to produce an NCN, right? And it's not going to matter where in the string it is. It's pretty independent of whatever's around it. So as long as I can track the pairs that are going on, if I've got 10 NNs, it's just going to result in 10 NCNs. And those are going to be kind of insulated from the rest of the space. Now, each of those n's is also in another pair, but I can track that and keep, that's okay. So if I'm going to try, it's kind of similar to whatever problem it was that we had the lanternfish that were pairing up. Like it just matters how many are in each state. It doesn't matter where in the where they are in the array. So let's try to think about how we're going to do this. So we're going to kind of start this fresh. Let's make this big so we can. Okay, so we start with our s, and we're not going to we'll do for I in range len s minus 1. That, and now we can do let's see, state. Actually, I can use a counter. I've already been using a counter. So state equals stuck on names here. Pairs equals counter of an empty counter. And so for each of this, I'm going to do pairs plus equals 1. I want pairs of, and so this will be s sub I plus s sub I plus 1. So what I'm doing here is I'm going through, so I'm going to loop over my initial string here, and I'm going to create a thing called pairs. And pairs is going to be, so I'm going to add, when I equals 0, I'm going to add nn, it's going to be plus 1. Then I'm going to loop, and then I'll add nc, will get plus 1, and cb will get plus 1. So the length is 4. I'll do a range from 0 to 3, which will be 0, 1, and 2 to get the 3 pairs. Okay, that's my prep. Now I can do for t in range 40. I'll do pairs 2 equals counter, and I will then, oops, no, and I'll do for pair in pairs, because I don't want to change. Okay, so that's fine. I'll then do have a pair, so that will be, so at this point I'll have something like, nn. I will do my thing called C of pair. I'll do pairs. It's getting confusing. Hope I'll make it clear. Of that plus equals, and I want to add in the number of pair of pair. Let's see if that makes sense. So when I loop through pairs the first time, I'm going to get pair equals nn. I'm going to look up C of pair. So nn goes, so literally it's C. So that's not quite right. So I need it to be, the new pair is going to be nc. So it's going to be pair sub 0 plus this new thing. It's going to be that. And pairs of C of pair plus pair sub 1 plus equals pairs. The word pair is starting to look really weird to me now. Type it too much, I guess. Okay, so what have I done here? Let's talk this through. That's because I want to do pairs 2 here. Okay, so when I'm going to loop over all of my pairs. To start with, pairs will be NN, NC, and CB. When I get to NN, I'll take N, and then I'll go find C. So NC, there's going to be that many. So let's say there's 3. In this case, there's 1 NN. So there's going to be 1 NC in the new pairs. And then I'm going to get CN, which also there's going to be 1 of those in the new. But if there had been 5 NNs, then there'd be 5 NCs and 5. Yeah, so that works. And I'm doing plus equals, not equals, because hypothetically I could get an NC or a CN from something else as well. I don't know if I could or not, but no reason not to just plus equals. Counter will initialize to zeros for everything. So that's nice. And is that it? So then I just need to come down here and do pairs equals pairs 2. I don't think that'll take long. I don't know if it's right. Syntax error. Okay, so maybe I'm doing something wrong. That looks right. C pair, that looks right. Huh. What's wrong there? Pairs 2 is not defined. It's not, I got syntax error, I didn't run. Let's see. We don't need to just get the line, current value 33. And we will mpdb break on C break on 33. C run. Still can't run because of invalid syntax. Invalid syntax. Okay. Should have been doing something really silly here. $34. Oh, but I'm looking at the wrong line. Let's see. Oh. That was just invalid syntax. Okay. Let's try again. Pairs. Okay, that's promising. I'm looking. I certainly have the right number of. I'm in large numbers, and I went really quickly. Let's say for a second that that's right. If that's right, what do I want to do? I need to then come back here and say I need the most common element. How do I get most common element from my pairs? I don't want to, everything will get counted twice if I just sum up. Like if I add all the ones that have B in there, I'm going to get, so what I'm going to do is I'm going to loop over the, okay. Pairs that these, yeah, okay. So if I do x for x in pairs, I'll get the list of keys again. And if I do x sub 0, I'll get the first ones. Let's see. Dot items. Let's see if I can do P sub C for pair for that. And so then if I do, getting too confusing to do a list comprehension. Let's do, so we'll do 4 P in pairs. I just need to count. Who'd have thought getting this answer? Like, I feel like I did the hard part and now I'm stuck on like how to actually get it out of here. So I want to add, we'll do counts equals counter. And then we'll do counts sub P sub 0. So that'll give us the first letter. Plus equals pairs of P. So that's going to give me, it's going to give me just whatever the first letter is of all of these. And that's fine, but I'm not going to get, so every one, again, let's say I was doing that over just these 4. I could take the NN and get the count here, and that'll give me the number of N's. Give me the N's there. Then I could do this NC and get the count there and add that to the N's. Then I could get the CB and add that to the C, and I'd be done. So now I need somebody to get the B off the last pair. Luckily for me, the last pair is always going to be the same. In fact, can I just do this last B? It's always, my string is always going to end in B, no matter what, because you always insert to the middle. So it's always going to start with N and end in B. So do I just need to add one B to the end? Counts of, let's see, it'll be the S to the S minus 1 plus equals 1. Because I just missed that 1B. It feels too easy. Let's try it. Help if I close my brackets correctly. 15, yeah, so let's see. Once I have that, now I can do my same, let's see, like this. I even called it counts again. Ooh, that's a big number. Okay. 2248 ending in 0274. Not quite. Let's check our H, because that's not the least number of times. So let's look at pairs. Let's kind of do this manually here. I'm just going to echo that so I have it. Things that have H in them. In fact, actually, I can do that is what I can do. I name pairs X for X in pairs if H in X and now we'll get all the H's and we can sum that. It's way too big. Oh wait, but I don't want that. I want if. That's probably still not right, but X sub 0 equals H. Still too big. So we have to figure out, do we think the problem is in the, is the problem up here or is the problem in how we're getting the counts? I think I just showed that the problem is not, let's make sure I didn't reuse any variables or anything. Let's see. I'm gonna be really careful here and comment all of part 1 out so I make sure I didn't screw that up. Okay, so counter, I'm gonna go through and make my counter here of pairs. Let's go back and, oh, I know what we can do. I have an idea. Okay, let's check here. Let's make this range 10. And see what it looks like after 10. So pairs is that. And I know from the first problem, actually now I'm regretting commenting this out. add this back in because I would like to see that number. 1588. So let's see. What is, we know B. Let's see. B was there. Where's our part 1? B was 1749. Whoa, way more. My logic is definitely off. Oh, I'm pretty sure I don't need to add. Oh wait, where am I here? Do I need to add 2 pairs each time? Yeah, I do. I wonder if my whole approach is off here. I'm going to pause for a second and think and restart when I'm not just giving you dead space. Okay, I started this a bit longer, and I think I see the problem. Let's do some checking here. So come down here and we do pair. Yeah, this is it. Look, so I'm here. I'm initiating my pairs, right? But the problem is I've already made S huge up here, so I'm not dealing with the initial S anymore. So my instinct originally to get rid of this was very much a good one. And somehow I managed to convince myself not to do that. And let's put that comment in there and run this again. And if that's the whole thing, then that makes me kind of sad that I wasted time on that. But yeah, that looks, shoot, 1769. So 1749 minus 161 is 1588. Yeah, that was silly. So now I just need, let's yank, paste, part 2, max counts values, min counts values. Let's see if that works. Oh, but I need to change my counter. It's not 10 anymore. It's now 40. $21.88 ending in 35.29. 21.88, 35.29. We got it. So that was another. That was a silly answer. Messing with my same input array twice really got me there. Oh, man, wasted some time on that. Let's go back and take a look and clean up here. We can make this print both answers at least. So let's see. We'll leave this commented out. We'll come here. We'll do this for range in 40. So if t equals 10, then we just need all of this, just all of it. Like that. Get rid of these faces. One like that. And then we continue. We come down here, clean that up. Let's see if that worked. 2233, was that the original? Is that my original answer? 2233. Cool. So that worked. Let's do a quick review here. So for part 1, basically I just looped through this string and I built a new string. So each time I had a pair, it became 3, which effectively doubles the size of the string because everything but the last character has a thing added. I think every character except for the last character has a character added after it. So you get n minus 1 times 2. And so that's why we're adding in, for every character but the last one, we're adding in 2 characters to the new string. And then we just add the last character to the string, and we then loop over time. Easy enough. To solve it the second way, though, we needed to stop thinking that way because the exponential growth got too big. So instead, we'll think about the fact that the pairs, all it matters is the number of each pair. So if you've got, for every nn you have, you're going to get an NCN. I mean, that's just the, or you're going to add a C. For every n, you're going to add a C. For every n, B, you're going to add a whatever, And so we're storing them in pairs, and we go through the initial string here, and we create this list of pairs. And then we loop over our pairs, and each time we then, if we have if we have 7 n ends, we add 7, we now have, we have 7 n ends, that would be P here, then we are now going to have, oh, sorry, ignore that, that wasn't. We have 7 n ends, pair 0 plus pair. We're going to then add 7 to nc and cn, because now we've got those, we've created those. And then again, we don't have to worry about the end here because the end is always taken account because we're working in pairs. But then because we're using this data store, it's much faster, but it makes calculating the answer a lot harder. So now I have to loop through here and take basically for look, I'll just look at the first character. I could also just easily look at the last character and then add count sub 0 here, or counts of s sub 0. The idea basically is each, with the exception of the last one and the first one, every other one is counted twice. And so I'll just key off of one of the two of those. And so I loop over, in this case, all the pairs, and I just look at the counts for the first item in the pair, knowing that the last item in the pair will be counted in the next pair, except the last one isn't, so I need to add that one to the end, and that will give me this. I really probably could write a function called like get score, and get score takes in all of this and does this, so I don't have to have this code repeated twice. I'm not going to take the time to do that right now. It's simple enough. But otherwise, yes, that's it. First day that I got like really stuck to the point I had to stop and think for a couple minutes, but certainly an interesting problem, and hopefully you enjoyed it and learned something. I will talk to you next time.